So we have this RLC series circuit, and we're asked in part A to find the resonant frequency. Remember, the resonant frequency F naught would equal omega naught over 2 pi. So we need to find omega naught first. Omega naught in this case will equal 1 over square root of LC, which is 1 over the square root of 0.40 times 10 to the minus 3 henries multiplied by 100 times 10 to the minus 12 farads, which gives us about 5.0 times 10 to the 6th radians per second, which means that F naught equals 5.0 times 10 to the 6th radians per second divided by 2 pi radians, which is 8.0 times 10 to the 5th hertz. So this is, if you want, almost like a lower part of AM radio, if you still listen to AM radio. Part B asks for the inductive reactance, the capacitive reactance, and the impedance. So X sub L, if you remember, was omega L, which means this is 5.0 times 10 to the 6th radians per second times L, which is 0.40 10 to the negative 3 henries, or 2,000 ohms. X sub C, if you remember, was 1 over omega C, which is 1 over omega, again, 5.0 times 10 to the 6 radians per second. C in this case is 100 picos. Do this, and you also get about 2,000 ohms. That means automatically that Z is equal to R, which is 500, right? Because XL minus XC is going to cancel out in this case, right? Part C asks for the RMS current. IRMS would equal VRMS over Z. We're told that the RMS voltage is 1 volt. We know that Z is 500, so this is 0.0020 amps, or 2 milliamps if you want. Part D asks for the RMS voltage across each circuit element. So VRMS for the resistor would be IRMS times R, which is 0.0020 amps times 500 ohms, which is 1 volt. The RMS across the inductor is IRMS times the inductive reactance, 0.0020 amps times 2000 ohms, which is 4 volts, and likewise VRMS for the capacitor is IRMS times the capacitive inductance reactance, which is equal to 4 volts again, just like the inductive RMS.